What's up, guys? It's Brian from Cross Coast Gaming with another Java game programming tutorial. So the last time we left off, we added our enemy class and we drew him here. He's seen better days, not very well blended with the background, and I said last time we're going to fix that, and it's not very difficult. We're going to go to the artist class instead of our helpers, and here instead of our begin session method where we kind of initialize all of the OpenGL calls for what we're going to be doing, right below where we enable 2D textures, we're also going to enable GL underscore blend. And this will allow us to blend with the background on the alpha channel, which is the transparency of an image. And after that, we need to call a function. So GL blend func for function. And it takes 2 arguments, and these aren't very intuitive, and they're kind of antiquated. They're not very easy to understand here. GL src alpha is the first argument here, and the second one is GL 1 minus src alpha. Alright, so we enable blending, and then we set the settings for our alpha channel and how we're going to blend that. So, you know, previously it was just black and white and there was no kind of transparency going on, and that should fix that. So let's try and run that now. Sweet. Looks better. I'm still not so sure about the texture I made for it, but it definitely looks a lot better than it did before. And so the next thing we're going to do is we're going to start our clock class. And this is perhaps not very exciting, but very, very important for a lot of the stuff in our game, because obviously a lot of the stuff relies on time as far as, you know, enemies moving, bullets moving, times between waves. All of that is going to be relying on our clock class that we make. There are some default already built in timing measures, but I feel like it's better to make our own because we can expand on it and make methods to pause the game or increase the speed, decrease the speed, etc. So we're going to do it in our helpers class. It's going to be our second helper here. Go ahead and name it clock. And we're going to make some variables at the top. And remember to make them static, because just like our artist, we want them to be accessible from our other classes. And the first one's going to be paused. And we're not going to build our pause feature right at the beginning, but at some point I feel like we're going to add it, so might as well just get that out of the way. Next is going to be our long, which is just a really long integer. And we need one for last frame and one for total time. And these variables I'm kind of making ahead of time, but it'll make sense as we fill out the class, hopefully. And finally, public static float d, short for delta time, which I'll get to in a second, and multiplier, which is another thing we're not going to add quite yet, but that'll be able to kind of slow down the speed of the enemies, you know, speed them up, etc., etc. Pretty cool once we implement it. And so those are all of our variables we need, and we're going to start putting a couple methods in here, and we're not going to do all of them in this video, but public static long, so it's going to return a long number, get time. And this is going to call on some methods from the actual system. So sys dot get time, and it returns in milliseconds, so we're going to multiply it by 1,000 here, divided by sys dot get time resolution. Timer resolution, excuse me. Okay. The next method we're going to make is a public static float get delta, and this is where we're going to be calling on all the time for our moving entities and our moving enemies and towers and all that. The delta time, as is used in maybe if you've used Unity 3D before or other programming platforms, and also just in general, the delta time would be the time between right now and the last update to the game. And so we can kind of, it's used in big games like AAA titles to kind of compensate for lag too, to make sure that even if someone isn't getting all the data, they're at least moving at the same speed. But for us, we're using it just to move our textures around. So get delta, and we're going to put in long current time equals get time, which is the method we just made up here. And we're going to declare an int for delta equals And we're going to need to cast this one as an integer here because it is not by default. Current time minus last frame, which is that variable we declared up here but haven't set yet. And finally, last frame equals get time. Okay? And then here, so it stops giving us an error. We'll fill this out real quick. 0.01f. So what we're doing is every time this updates, okay, we're setting the current delta time between now and the last frame, and then we're setting last frame equal to right now. So the next time we call it, it'll be calling it between, you know what I'm trying to say? Next time we call it, last frame will be equal to right now. So in the future, it'll equal the delta time between now and the next update. It's a little confusing, which I totally get. But luckily, we're not going to be editing the clock class a lot after we build it. It's more just kind of accessing these methods that we're making. So it's okay if you don't understand it like 100%. Next, public static float delta. And this one is just kind of for our pause method. We're going to say if paused, which is the boolean we made up at the top, then return 0, because there are no updates going on, so there's no delta. Else, return d, which is our shorthand float we made up here, multiplied by the multiplier for the speed. And stuff like this, again, is going to make more sense after we're actually calling it from inside of our game and making use of it. All right, next is our public static float total time. And this is our getter. Instead of get total time, we're just going to call it total time because it's static, so we're going to be accessing it that way. And we're just going to return total time. And we're going to do the same thing for our multiplier, public static float multiplier. Return multiplier. And lastly, for this video, we're going to implement the update method, which we're going to call every time the game goes through an update cycle. So public static void update, update. And inside here, d, which is our temporary holder for delta up here, is equal to get delta. So we're setting it that way. And then total time plus equals d. And so plus equals is just the same thing as saying equals total time plus d. We're just adding d to total time. So total time plus equals d. All right. So it's not very intuitive. It's kind of confusing, and we're just going to get it out of the way. I was kind of putting it off for a while. I decided to draw the enemy first so you can see how it's going to be useful in moving our texture around. But we're almost done building it, and we're probably just going to add a couple more methods in here. And then all we need to do is just call those methods from our game. So it's kind of like the artist class. You know how this stuff is pretty confusing, but when we're actually just calling it, it's not that confusing anymore. So luckily we got our guy looking good here. And hopefully we can get him moving around pretty soon. Hey guys, it's Brian from Cross Coast Gaming with another Java game programming tutorial. So the last time we left off, we made our clock class, or almost all of it anyways. We're going to go ahead and add the last few methods just to finish this off so we don't need to deal with it later. The first one's going to be change multiplier. So remember, we made a multiplier up here so we could speed up the game and slow it down. So this is just a way to call that from another class and change it. So we're going to pass along an integer for the amount of times we want to change it. And we're going to check if our multiplier plus the change that we're instituting is less than -1 or, and multiplier plus change is greater than 7, then we're not going to do anything. Else multiplier plus equals change. And so the reason we're doing this is that we don't want to, these are just arbitrary numbers, by the way. You can totally change the 7 and the -1 when we get to a point that these actually matter and experiment around with those. But you don't typically want it to get much higher than that because your game will start to have a lot of performance issues, as well as lower than that. And dealing with negative numbers can sometimes make it a little wonky. Anyway, so that's our change multiplier. I swear I was going to add another method here. But, oh, right, the pause method. Public static void pause. No arguments. And we're just going to check if the game is paused, then set it to false, or else set it to true. So that's just using one pause button. If it's paused, unpause it. If it's not, pause it. You know, that we don't need a pause button and an unpause button. So next we're going to go to our enemy class here. And there's two, so far we've just been doing draw, right? And if you run the game, you can see everything is static, right? So everything's not really moving, or moving at all, I guess. And usually when you deal with movement or collision or damage, stuff like that, it's separate from the draw method. The draw method is really just meant to show the stuff on the screen where it is. So we're going to go ahead and make an update method. And we made one of these in the clock class as well, if you remember. Public void update. And at the top here, below where we import the artist, we're also going to import the clock that we made. And just go ahead and import all those methods there. And so for our update, we're going to say x, as in our position, plus equals delta times our speed. So the speed is set when we make the enemy, and the delta is a value that we set inside of our clock class to get the time between the last update. Now there's something that we need to kind of work around here because we're building a game from the ground up in a sense, so we're going to expand on a lot of this later. But for now, there's a kind of an issue that we're going to run into, which is the very first time the clock calculates delta, it's going to be huge compared to the rest. So usually we're looking for a value smaller than 1 for our delta between the last update. But the first time it calculates it, because everything's kind of booting up, it's going to be a huge number that'll just put our character totally off the screen. So what we're going to do is make a temporary fix here. And at the top, we're going to make a private boolean first, and we just set it up here. It's just temporary. Equals true, as in it's the first time that this is being run. In our update, we're going to say if first, meaning if first is true, then set it to false, else do this, do the update. And so really that's just saying the first update, ignore it. The clock will then calculate the delta again, and we'll just continue from there. This only happens the very first update of the game, the very first time the game's run. So the last thing we need to do is go to the boot class here. And first we need to update our clock, so clock.update. And below that we'll do e.update. You always want to do your updates before you draw the characters. Clock.update, e.update. E is the enemy that we set up here, if you remember. The speed is 2, which might be too high. We'll see. Actually, let's just set it to 1 for now. And let's go ahead and see how that looks. Sweet. Okay, so it definitely wasn't too high at 2. He's going pretty slow. So really right now we're just seeing our enemy move across the screen. Okay. And remember, if you want to change the speed of each enemy, you just set this last value here to whatever you want it. So 3, for example. You can see he goes faster. All right. So this kind of update and then draw is going to be the basis of all of our movement in the game, including projectiles, enemies, towers, player cursor, you know, everything like that. He'll eventually go off the screen there. So that's about it. Hey guys, it's Brian from Cross Coast Gaming, and this is another Java game programming tutorial. So the last time we left off, we had our little guy run across the screen here. And what we're going to do this time is we're going to make a simple kind of backbone for a wave class. So go ahead and make a new class named wave. And we're going to set up our, oops, let me move the mic here a little bit. We're going to set up our variables we need at the top here. So private float time since last spawn and spawn time. And they seem similar, but they should become apparent what they are when we incorporate them. Next, we're going to take a private enemy type, and a list of enemies, so private array list of type enemy named enemy list. And we probably need to import that. Yep. And that might be it. So let's make our constructor here, public wave. And it's going to take a spawn time and an enemy type. And once we have that, we're going to set, enemy type equal to enemy type, oh my gosh, and spawn time equal to spawn time, and enemy list equal to a new array list of type enemy. So that kind of initializes the list, says we're ready to add stuff to it. And next, we're going to work on our update method. So inside here, we need to import the clock too. Import static helpers clock. So inside of our update method, we're going to increase our time since, that reminds me too, in our constructor, time since last spawn equals 0. So we're going to increase our time since last spawn by the delta time that has passed, which we get from our clock class. And then we're going to check if the time since last spawn is greater than the amount of time we want to pass in between spawns. We're going to call the spawn method, which doesn't exist yet, and we're going to set time since last spawn to 0 because we just did it. And now let's make our spawn method. And how that's going to work is we're just going to add a new enemy to our enemy list. Enemy list add new enemy. And we're going to need some values from the enemy class that we don't currently have access to. So like the texture and the start tile and stuff like that. So go to the enemy class, and you can see these are private, so we need to create getters for them so we can access them from outside the class. So just click here below the, or in between the last two brackets, and go to source, and then generate getters and setters, and we'll just select all of them. Alright, now we go back to our wave class, and we could say enemy type dot get texture, enemy, what's after that? What do we take in our constructor here? Texture, start tile, width, height, speed. Okay. So then we can say texture tile, so enemy type dot get start tile. We know that's going to be 64 and 64. And the speed, get speed. Put a semicolon at the end there. Alright. So that adds a new enemy to our spawn. It creates a new enemy. Adds it to our enemy list. So what we want to do now in our update method is say for each of our enemies, enemy E, inside of enemy list, you want to update them, and we want to draw them. And we're probably going to reformat the way all of our updates and draws are kind of situated, but as we're building this wave class, we're just going to keep the enemy update and draw right next to each other in here. I think that might be it. Let's go to the boot class now. And right below where we make our enemy, we're going to make a new wave. Wave equals new wave. And it takes a spawn time, so we'll say 10. And an enemy type, we'll just say E, because that's the enemy we made right up here. And we can get rid of E.update because we're doing that in our wave class. and also e.draw. And we can replace that with wave.update. And let's see. I think that should work. Let's try it out. Oh, no, error. Null pointer exception from enemy line 18. Start tile.get x. Alright guys, I kind of skipped ahead a bit because I figured out what was wrong. So the issue is, it's pretty silly actually. If you go to our 18th line of our enemy class, you can see us do with our start tile, which is called when we add a new enemy here, and we're getting the start tile. The issue is that when we're making a new enemy, we're passing it a start tile, but we're never actually setting it to this thing right here, to our local variable of the start tile. So we're calling get start tile somewhere in here. We're returning this thing that's never been set to, which is our null pointer exception. So all we need to do is inside of our constructor for our enemy, we're just going to say after the texture, this dot start tile equals start tile. And now let's try running it. Cool. And there you go. So now we got a wave. It's actually pretty perfectly spaced out. I didn't even plan that. But you can space them out some more. All you need to do is just go to the wave and change this number to something higher, like 20. And they should be twice as much time before they spawn, like that. But yeah, now we got a wave. So it's looking more and more like a tower defense. What's up guys, it's Brian from Cross Coast Gaming, and this is another Java game programming tutorial. So the last time we left off, we made our wave class, which allows our enemies to spawn intermittently and forever as of now. And this time we're going to create our player class, or at least the beginning of our player class, which is a way for us to kind of interface with the world that we're in. So let's see. We're going to want a couple variables up here. I think first we're going to want a copy of the grid. So tile grid, and we'll probably want, well, we're going to want a list of the towers we're going to make eventually, but we don't have the tower class created yet. So I think actually all we need for the constructor is just the grid. So public player that takes a tile grid. We're going to say this dot grid equals grid, and let's make something to allow it to directly interface with the game world. So some of you were asking in the comments to make some kind of level editor or to expand the one we have, and the first step of that is to change the tiles with our mouse, pretty much. You'll see what I mean, I guess. So we're gonna make a public void set tile method. And I know that the grid already has a method similar to this, and we're going to make use of that. But we're going to implement some kind of input from the mouse here. So let's see. Let's do grid.set tile, the x coordinate and the y coordinate. For the x, I believe it's going to be mouse. We might need to import something here. .get x, maybe not. Oh, imports automatically, so make sure you import that. Mouse.getx, that's tracking the x coordinate of our mouse cursor, where it currently is. Divided by, divided by the tile size, which is 64 for us. And I think that should be it. We should floor it too. So before mouse.getx, say math.floor, and you're gonna put, not floor div, just floor, and put this stuff inside of that for this x coordinate here. Not floor div, what the heck? There we go. So math.floor, what that does is it's kind of like rounding, except it only rounds down to the next whole number. So math.floor, mouse is, there's some kind of tsunami warning going outside, but the show must go on, you guys, even if it's the last thing I do before my house is swept away. grid.setTile. I just hope it's not too loud in the audio. Math.floor, mouse.getX, divide by 64, which is the size of our tiles. And then for Y, it works a little bit differently. We actually need the screen height, which, do we have that anywhere as a saved in a variable, screen height? Not yet. Let's see, where do we initialize the, oh, it's in the artist class, that's right. Helpers, artist, height. Okay, it's inside the artist class. So let's, in our player class, let's import the artist stuff. Import static helpers dot artist dot star, and now we should have access to the height of the screen. So for our Y, it's gonna be height. Well, actually, to start, it's gonna be math dot floor, and then inside of these parentheses, it's going to be height minus mouse dot get Y minus 1. And we're going to divide all this by 64. So we're actually going to put another parenthesis, put more parentheses around this. Oops, didn't we do that? There we go. And before the last one, put divided by 64. And here, let me put this on the new line so it looks easier. And type. Oh, we need a tile type to change it to. So tile type dot water. Set tile. Why is that not working? Int tile type. Oh, we need to cast it as an int as well. Int, because I think it returns a float. All right, so we have no errors. So hopefully this all works. I think it should. I think the math is correct, but if not, we'll tell what's wrong. Now we just need some way to activate this. So let's see. There's a couple different ways we could do it. Let's try for now just putting it inside of our update so that it runs every time. So we'll actually just call setTile and see if the changing of the tiles even works. So after we draw and after we update, let's call, well, first we need to make a new player. So below our wave, let's say player equals new player. We need to set our grid in there too, so send it grid. And then after wave.update, let's do player.setTile. And if it worked, then it should change the tiles that our mouse is over to water. All right. Cool. So this is kind of the beginning of our level editor. At least a better way to edit levels than we have right now, which is just all the characters inside of the code. Obviously, we'll make it so you can switch tiles between water and other stuff, and we'll also obviously make it so that you need to click to change it. But that involves some keyboard inputs and also some mouse clicking inputs, so I figured I could just do that next time and keep it nice and short and simple. So that's it this time. What's up, guys? It's Brian from Cross Coast Gaming with another Java game programming tutorial. So the last time we left off, we modified or created our player class and made it so that everywhere our mouse goes, it just leaves chaos in its wake. And today we're going to spend some time making this not awful. You know, pretty much just making it so that there's not water everywhere you go, because obviously this is very temporary and not something we want to keep in the game. So let's go ahead and go to our player class, and that's where most of the stuff we do today is going to take place. And first and foremost, we're going to make a new method for updating. So make an update method for our player. And we're going to say if the mouse.is button down, and you can choose an integer to put in here. So it's 0 or 1. 0 is left click and then 1 is the right click. There's other button or numbers you can put in there too, but 0 and 1 are left and right click. We're going to say then that is when you call setTile. So first, let's try that. Let's go to the boot class. And instead of saying player.setTile and calling it directly, we're going to call the update method. And now, if we run it, it should only go, it's not going now, it should only go when we click. There we go. So we have a little bit more control over what we're doing. So that's the first thing we're going to do. And also, we're going to make it so that you can draw different tiles. instead of just water. So at the top here, let's make a private tile type array. I'll just call it types. And we'll say this dot types equals a new array of tile types of size 3. I think that's how many tiles we have right now. And then we'll say this dot types at 0 equals tile type dot grass. This dot types at 1 equals tile type dot water. And this, I'm going to switch those two. This dot tile types 2 equals tile type dot water. And I'm going to make the last one dirt, because I think that's the order that they came in. So 0, 1, 2 is grass, dirt, water. And we need another integer up here, or another variable. Private int index. And we'll set that in the constructor. This dot index equals 0. And so now down here, first off, we're going to change where we set it to water automatically. We're just going to change that to our types, the array that we just made, at the index, which is the integers we just made. So types is a list of all the tile types we have in the game, grass, dirt, and water. And then we're going to access each of these specifically by putting an index variable in there for 0, 1, or 2. So by default it's 0, which is grass. So we just need a way to, in fact, if we start it right now, we should be drawing grass, yeah. So we just need a way to change that index now. So in our update method, we're going to say while keyboard.next, and that just means that the keyboard's doing something. There's like an event that's happening that we're about to process. We're going to say if keyboard.getEventKeyState, as in the key that's being pressed. I think we just set that equal to the key. Let me see. I might be wrong here. We're going to say key underscore right. Did I do that right? Undefined for argument types, boolean int. Keyboard.getKeyState. Maybe it's, let's see, if keyboard get event key. There we go. So instead of get event key state, it's get event key equals right. Let's see if this works. Let's just print out right. Oops. Put a semicolon there. And if it worked, then when we hit the right arrow key, we should see something pop up here. And it'll probably happen a bunch of times when you just hit it once. Like that. That was 2 times. A bunch of times there, yeah. But it's working. It's seeing our right key. And if we hit left or up or down, it doesn't do anything, so that's good. So now we just need to limit it to 1 time per press. Because what's happening right now is when you're pressing it down in that split second that you have the key pressed down, the actual game is running over and over and over and processing that the key's down. So instead of just checking if the key's down, we're also going to say and keyboard.getKeyEventState. I think that is what we want here. Now let's run it. Yep, there you go. So now it just runs it 1 time per press. Perfect. So what we really want to do is, instead of just saying right, because that's just to test it, is we're going to make a new method here. Private void, I don't know what I'm going to call this, move index, I guess that works. And we're going to say index plus plus, we're going to move our index variable up 1, or add 1 to it. Now we're going to check if index is greater than our length of our types minus 1 because of the way it works. Because remember, even though it's 3 big, it actually only goes to 0, 1, 2. So if our index is greater than the length of that minus 1, so if it's greater than 2, then we're just going to set index back down to 0. So that way we can cycle through it. It starts at 0, adds to 1, it's good, adds to 2, it's good, adds to 3, it's good, and then next time it says it adds to 4, so we're going to set back to 0. So it just cycles through it over and over. And here, instead of saying right to the console, we're just going to use our move index method. And let's try running that. So first should be grass. Let's erase everything, get a nice clean board here. And if we press to the right, I believe it should be dirt. Yep, so we can get a nice little... Imagine that these guys went along a maze to get where they're at and not just appearing in the middle of nowhere. Oops. Luckily I can erase that. Cool, so that's a kind of tower defense map, and if you go to the water here, you can fill it in and say that this is a reservoir. I don't know, honestly I could do this forever, just playing with this little tile editor thing. And we're going to get to the point eventually where we can obviously save the maps and then load them. But this is by far the easiest way we've had so far to make our own maps. So feel free to have fun with this and experiment around with it. And pretty soon we're going to be making a save and load feature for these maps.